a question here. So the question we're asked here is to find this length x. Remember, we look at a couple of things, Pythagoras, and the other thing was SOHCAHTOA. So whenever you're going to see angles, associated with those triangles within the circles, and you're asked to find the length, so just remember what we need to do here is we're going to try number D first. Okay, so question D here, because I'm looking, I've got an angle, oops, because I've got here 110 degree, what I need to do, I'm just going to pick a pen. I'm going to try and see if I can find this distance. Because if I can find this distance, and I know that going through this, you get this distance the same as this distance. This is 12 meter. Okay. And I've got here 110 that I have half. So that means this angle here is 55. So this distance here from there to there to there is the same as this distance here. So the first thing I'm going to do, because I've got an opposite side, which is 55, sorry, I've got an opposite side to my angle of 55 degree, which is 12 meter, and I've got the angle. So I can say, if I use SO, opposite and hypotenuse, sine 55, so the sinus sine 55 is equal to opposite side 12 divided by hypotenuse, which is what we're going to call it y. Let's say this is y. And at the same time, so once I can find y, now that I've got y equal 12 divided by sine 55. So what is that? So 12 divided by sine 55. So what you do is you just time by y both sides, and then you divide by sine 55 both sides to use your balancing method. So 12 divided by sine 55, and the answer to that is 14.65, 2 decimal place. Yeah?
Yeah, 14.64.
So 14.65. So I've got the hypotenuse, which is 14.65, yeah?
Mm-hmm.
And because it's the radius, I've got this as well, 14.65. So I've just used SOHCAHTOA, and I've got 14.65. Now, what I can see is the only side that is missing for me to get x is this bit here, that length there. Because I've got 14.65 here, I'm looking for that length here. And this time I'm going to use cos 55. Okay, so cos 55 is adjacent divided by 14.65. So adjacent side, yeah, so cos 55 time, so cos 55 time 14.65. So what's that? So you do 14.65 time cos 55 if you want. 14.65 time cos 55. And that gives me 8.4. So that length here is 8.4. So I've got 8.4 here and 14.65. X, you just add those two together. So 8.4 plus 14.65, and that gives me 23.05. So X equal 23.05 meter. Okay. And my value makes sense because slightly less than the 24. It's more than the 14.65 there. So we needed to use SOHCAHTOA, cos to find one side, sine to find the longer side first, and then we add those two together to give us X, what we were looking for. And these other examples are very similar. Here you're looking for the longer side, hypotenuse. Here you would do something similar to this, but trying to find X. And here you'd be trying to find that. If you can find half of it, you double it. So I'll let you work on those. They're a bit challenging, but like I said, it's by going through them that you will learn how to extract what you're looking for, okay? In this example here, I've got a set of part gates. So this one was question 21D, question 2 and 3. So let's have a look at question 2. Yeah, so this one, a set of part gates. I need to get rid of this. Or should I just open my book? It's probably going to be easier. So a set of part gates from part of a circle. So we've been told that the radius is 4 meters. Okay. The width of the gate is 6 meters. Calculate the height of the gates. So what can we use here? So when you look at it, what you need to do here is you need to do a wee sketch. So the sketch would involve putting a radius, 4 meters. We're just going to put what we've been given. Then we'll put the 3 meters here plus another 3 meters. That's the 6 meters here. So I've got 3 meters here. And I know that from here to right to the end here, where the circle is, I've got 4 meters as well. So what I'm looking for is this distance here, x. Because once I can find x, and I know this is 4, then I'll be able to extrapolate or deduce what h is. Because I know that x plus h equals 4. So if I can find x, knowing that this is 3, this is 4, and you've got right angle here. So what you say is x is square root of my longest side square, which is 4 square, take away 3 square. So that's us just using Pythagoras. Okay. So and if you do that, then you get 2.65 to 2 decimal places. 2 decimal places. Okay. So h is just 4 minus x. Four minus 2.65. And that is 1.35. 35 meter. So the difficulty here was to redraw what we've been given by making sure that we've got a 4 meter radius here. And because you have this, you've got 3 meter here. And that's how you would get all your marks. So that would be 1, 2, 3, yeah, 3 marks. Okay. So that's how you would go about these kind of questions. So let's see if we got more. So this probably will be more of a self-study, but because sometimes you get these kind of question, you've got interior and exterior. So they give you a shape, okay? So this is the bit where they give you a shape and they ask you, it's usually a pentagon or an octagon or a shape with equal sides. Because they're equal sides, and you know that all angles around a point, so the angles around the points makes 360. So if you've got like a hexagon or a pentagon, like in this case we've got a pentagon, so we've got 5 sides that are equal, then you can divide that into 5 isosceles triangle. So that means A is just 360 divided by 5. So that's how you would find that first angle. And once you've got A, because you know that all angle in a triangle add up to 180, you can find B, which is just 180 take away A, and you divide that by 2. And that gives you B equal 54. So question that sometimes you get asked during an exam is, what is the value of this angle here? And you know that it's B plus B, which is 2 times 54. And that's 108. And that's what they call interior angles. So if you look at the shape, you've got what we call an interior angles, is those two angles, 2Bs, give you the interior angle. Now, what do they call an exterior angle? So an exterior angle, you just imagine that you keep drawing these lines, and basically it's just 180 take away B, which is 180 take away 108, and that's what they call the exterior angle. Okay, so in case you get asked, what's the exterior angle from this shape? That's what they mean by that. You find the interior first, and then you take away 180 from it. So I've seen questions like that coming. So maybe when we're going to do more of a past paper type question, we can go through them. But again, they do use the same kind of method of using isosceles triangle, angle around a circle, and a straight line. Okay. So I'm gonna finish recording